Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining this episode of Neo4j Live. Today, we talk about the book Graph Algorithms for Data Science, and I'm super happy to have Tomaz Bratanic with me today. Hi, Tomaz. How is it going?
Hey, you kinda almost nailed my name, which is quite commendable. So yeah, I'm doing very good. How about you?
I'm good as well. I'm looking forward to this episode. How is the proper
I mean,
pronunciation?
it was good. Like it's Tomaz and then Bratanic. It's like nobody has the ch, but
Okay, Bratanic. Okay, good. So now I know. It's good to know because I have been using your name in the past for almost for a long time, and I'm planning on using your name for for a long time as well because you are super active in the Neo4j community as well as in posting blogs and answering questions in the community. But as I mentioned, also posting blogs. So you have a very active Medium blog where you post. I mean, it feels sometimes like every week is or maybe more often than once a week. You post something pretty amazing there, but you are super regular. So I think I just opened it up. Latest post from you was on March 30th of March, so a couple of days ago, and then in February and so on. So
yeah, I mean, I used to be more active.
yeah.
Now I do a bit more coding. I mean, integration as well. But yeah, I think there's like 80 or 90 Medium articles.
Yeah.
It's a lot. It's a
that's
lot.
that's a lot, and it kind of kicked off. Well, it for a long time, but I think you went really on fire towards the course of last year when you wrote lots of articles, lots of posts about artificial intelligence, Gen AI, LLMs, integrating knowledge graphs, integrating graphs with Gen AI, with RAG. So
Yeah, but
very,
the
very
funny
interesting.
thing is that like this like NLP, like natural language processing topics were always interesting because I wrote like let's say one or two a year.
Mhm.
They got like five times as many views as the other blog posts. So like
Okay.
NLP, uh, like natural language processing and like things around that. That was always interesting. It's just that now that with LLMs and Gen AI, that's more at the forefront, right? Because
Yeah.
LLMs make life much easier.
Yeah. Yeah. And I mean, it's the hot topic these days. Everybody is talking about it. Everybody wants to say something about it. Everybody wants to use it, wants to play with it. So it's only natural that the interest is high, and we do a lot with it as well here at Neo4j. So there's a good, I think there's a good connection and a good reason for it to use these tools but to also pair them with graph technology. And I think we talk about those in relatively often on these streams. A couple of episodes in the past, we had interesting guests to showcase what they're doing. We have together with Jesus, I'm doing a Going Meta live stream series, which talks about these things as well in the past. So it's a very interesting topic with lots of content, and very very interesting to see what's happening, how the technology evolves, new discoveries, new ways of working with data, new ways of playing with that on that field and try things out, and also to make things work and to implement things in the end, and to benefit everybody. So that's a cool thing.
Yeah.
Yeah, and you've been also a little bit of a mentor, I would say, in this space for many
I
people.
call it thought leadership.
Thought leadership, exactly. Yeah, yeah, totally. Um, you inspired lots of people that have been out in the field and read your articles and then tried out themselves, play with it, and then post themselves something about it, and lead on to how then themselves become influencers or thought leaders, I guess, or at least experts in the field, and to share the voice here and to share the stories. So that's really cool.
It's quite awesome to see that like you plant an idea and then you see like growing it, like people giving their own touches and like inputs, and then making it something great.
Yeah,
I think that's awesome.
Yeah, absolutely. No, that's very cool. Very, very, very good to see. And I guess that's a little bit how you decided to write a book. Is that one where you want to kind of like collect your knowledge and then summarize it in one space? And
Yeah, I mean,
share it
the
with
book
people?
was kind of funny because, as you know, I've been like writing a Medium blog posts. Like even before Medium, I had like WordPress blog posts, which probably nobody knows about. But I had WordPress blog post for like 2 or 3 years, and then went to Medium.
Mm-hmm.
But then it was like I remember exactly, there was like one blog post that I did. It was kind of long, and it showed basically how to build very relevant topic, how to build knowledge graphs from text. And
Mm-hmm.
that was like maybe 4 years ago or something. And I think we used some like Google API for like topic detection, and then like named entity extraction from Amazon or something like that. So it wasn't like today, right, where this is all much simpler. It was like had to go to one provider for this, to another provider for that, and then kind of combine everything, and it's all very static, not flexible.
Mm.
Yeah, but anyway, I showed how to build a knowledge graph from text, and it was like at the end, it was like a very long blog post. And then at the end, I say, if I am ever going to write a book, this is going to be a chapter in the book.
Yeah.
And then you know what happened? Michael said, Michael Hanger. I mean,
course.
let's write a
Yeah,
book.
of course.
And
Yeah.
that's how it went. And then he said, I mean, yeah, but let's write a book. Why not? I mean, by we, I mean you.
Yeah.
And then he got me in contact with publishers, and that was that.
Well, I mean, he at least contributed the foreword, so he did something. But I mean, yeah, I can imagine how it went. Yeah, I mean, you is like, yeah.
I mean, he was helpful also along the way with like syntax and book, and he did chapter reviews, and
Yeah, absolutely.
all over the place. But yeah, it's basically Michael, because it's also Michael why I work for Neo4j in the first place. Because maybe that's even like before the book happened, like long time ago, like 7 or 8 years. Neo4j didn't have a graph algorithms library.
Yeah.
I mean, and before GDS, it was called graph algorithms. And I started writing content and contact Michael when graph algorithms, the first library that now doesn't exist anymore, was being developed. And I said, I like to write content for around Neo4j, and do you have any work for me? Basically.
Yeah.
That was, and then he said, yeah, I need someone to write documentation for graph algorithms library, right? Because it was a labs project, so it means not
Yes, I remember.
officially
Yeah.
supported, so like external contributors. And he said, yeah, I need someone to help with graph algorithm library documentation. And I said, yeah, fine, why not? I mean, what's the worst that could happen, right? And then that was like 7 years ago. And then they implemented some like first 10 algorithms.
Yeah.
And then I was like when in the beginning I was like reading research papers, algorithms, how people are using it, like what to do, but also like giving like user experience feedback, like a little bit. I help a little bit with standardization of parameters, stuff like that. So that was basically, it was all meant to be right. The second I started to work for Neo4j, I was writing documentation about graph algorithms.
Cool. Yeah. And now you went on and written a book. It's called Graph Algorithms for Data Science. So it's a little bit, like you said, the evolution from the original graph algorithms, without the library part, where we had like they were like a little bit standalone in their own world, and now we have a proper graph data science library and client that's fully integrated with Neo4j, and that's part of Neo4j, and that the book covers different algorithms and showcases them across.
Yeah, I mean, actually, it's designed because unfortunately, most people never worked with graphs,
Mhm.
right? So it was designed to take a complete novice or someone who never seen graphs before or used them before and teach them, right? So the assumption is that
Okay.
the user knows a little bit of Python. Maybe they do like a pie chart or bar chart in Python, just like some basic data analytics, but they have no idea about graphs or Neo4j or anything like that. And then the idea is to take them and like educate them first a little bit about what are the graphs, like when to use them, how to model them, and then in the next two chapters we kind of go through what is cipher, what's like the syntax of cipher, and like also like how is it similar to SQL, how it's different from SQL, how to do like basic aggregations, stuff like that, right? So that's like gently, because I feel like that new users, like people who never like touch the technology, they need a lot of hand holding, right? Because you want you want it to work, right? Because like if I give you something and it like on the first try doesn't work, okay, you may try again. But like if on the second try it doesn't work, you're just gonna say, okay, that's not for me, goodbye.
Yeah, yeah. You can be discouraged quickly, and it's
Yeah, and then
yeah.
say, yeah, I mean, whatever, maybe next slide.
Yeah,
And then that's why I take the approach of like really hand holding and like really gently introducing, because I want, like, you want those like small victories to motivate people, right? And have
yeah.
something working, right? Because if nothing is working, that's not really motivating, right?
No, yeah, you're right. Yeah.
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 So yeah, so it's the idea is to take a complete beginner and make them, I don't know what's the word, but you can like graph data science, because maybe I can share a picture.
Yeah, and we can so we plan to look over the book a little bit, give some insights, and show you a little bit what to expect there, and some learnings and some tips and tricks from Tomaz as well. So maybe that's a good way of doing it today. And also, if you have any questions, any comments, anything you want to know more about, then please don't be shy. Use the chat and let us know. We are also giving away a couple of free ebook versions of the book. So if you're watching this live, and if you are watching this on Twitch or on YouTube, because otherwise it's not going to work on the other channels. But if you're watching this on YouTube or Twitch, or you can switch over if you're watching if you watch it somewhere else, if you can switch over to YouTube or Twitch, then you can use !raffle, and you're in the pot. And later, maybe after we introduced a couple of chapters, we draw a couple of winners. Tomaz, remind me, how many PDF ebooks do we have? Like,
can do like 3.
okay. All right, that's good. 3, so that's a good number. So if you want to win that, then let switch over to Twitch or YouTube and use !raffle. And good luck with that. And yeah, here's the slide. Yeah, cool.
Okay.
Let's go there.
So now you can observe my diagram skills.
Yeah,
it was funny that because all like with the book, like images, right? It's all about copyrights. So in the end, like there's I don't know how many, let's say 100 pictures in the book, and like 99 came from me, and only 1 was from someone else. So I did a lot of diagrams and images as well. And yeah, this is the image. You can see it's on the second page. And basically how I designed the book, how I designed like to take a journey from a complete novice, right? And hand hold you, basically take you by the hand and make you, here we call it graph data scientist.
Yeah, that's good. That's cool. And that's like incremental, I guess. It starts so super simple and easy, and then you...
Yeah, like I said, so we started at first like what is a graph, like when to use it, how to construct it, but it doesn't go like into very a lot of details, but just like some basics about graph construction and modeling. And by the way, we use like Twitter dataset. I mean, can you still call it Twitter? Is it?
Yeah. It's probably has a different name now.
Still Twitter because it was written before X happened.
Yeah.
So yeah. So first we construct a knowledge graph. I mean, a graph of a Twitter dataset. Maybe I don't know. Maybe if I should jump around a lot or not.
Yeah, you can.
But yeah, I mean, there's the simple idea, right? How to describe a graph structure, then how to import it into a graph database, and then once we have the graph, we kind of do exploratory data analysis, right? And learn a cipher through the exploratory data analysis. So, like how many users are in the graph, how many posts, like what's the ratio between posts and users. Just some basic statistics can help you get into into the flow of writing cipher and using it for analysis. And then that's, I think, up to, so like graph modeling and construction is like chapter 1, chapter 2.
And you already call it graph query language. It's very, very, very up to date.
Yeah, exactly.
If you don't know why we're laughing, why it's a little bit of a joke. The ISO committee just published the GQL as an official database language standard, and it's called obviously graph query language, and that is an official standard now for databases, how to interact and how to query data with databases, graph databases, property graph model databases, and that's now an official standard, similar to what SQL is for relational databases as of past Friday, and it's called GQL. So it's very cool. We're very happy about.
Yeah, I had the first side.
Yeah, exactly. Yeah.
Yeah. So that's I think chapters 3 and 4, and then we could maybe, yeah, I don't know exactly, but yeah, somewhere around that, and then we go into graph algorithms, right? Because that's kind of the topic and the title of the book, right? It's called Graph Algorithms for Data Science.
Yep.
So we delve into graph algorithms and like the we start with the classical ones. So the classical graph algorithms are like finding the most important nodes using something like PageRank, or like finding communities of nodes, or like identifying similar nodes, and then also a little bit about indirect relationships. So that's like there's like 4 or 5 chapters about graph algorithms and how to use them, and it's all like if you read any of my blog posts, the chapters are kind of, each chapter is a standalone like tutorial. So you get like a theory introduction and then some nice diagrams, what we're actually going to be doing in the chapter, what's the idea. And we kind of put you into the scenario. So like imagine you're working at Twitter and want to analyze something, whatever, right? And then we actually do the analysis throughout the chapter and explain what we are doing, but also the results, right? What do they mean and how to interpret them. And then when you kind of get the hang of the classical graph algorithms, we go into the, I call it graph machine learning. I mean, this is some distinction I came up with, because also graph algorithms, they are also machine learning. Because like the typical graph algorithms like PageRank or like community detection, they are like unsupervised machine learning, where you basically say, here I have a graph, right, and I don't have any labeled information, so that's why it's unsupervised. And please find the most important node within the graph. So that's why it's unsupervised. But I specifically, I kind of mentioned the reasoning behind this distinction is that for the graph machine learning, I kind of say that here is basically we're learning in this book there are only classification models. We don't do any regression, so we actually train like a classification model, like a random forest model. So we use graphs and like node embeddings and all of that fancy algorithms for like feature engineering, and then we extract the feature vectors for nodes and use them downstream to train and inference in machine learning models like classification. So that's basically the gist of it. So yeah, like I said, the idea is to take somebody who's never seen graph algorithms and have them train a couple of machine learning models based on the graph. Okay, so I don't know how should we, do we just walk?
Well, but let's maybe pick a couple of chapters where you think are most interesting and give a good impression, and maybe where we can share a bit of additional knowledge and a bit of interesting bits where you think this makes a good impression, a good overview, and is maybe most interesting for the audience, and maybe we do that. Is that make sense to you?
Yeah, I mean it's totally fine. It's totally fine. So by the way, the first chapter is free, right? So if you're interested,
cool.
The first chapter is always free. I don't know how you go just on the website and click some, maybe look inside. Yeah, and you get the first chapter, because I have the actually I'm not signed in, right? And you can see.
Yeah. Oh, that's good. Yeah. So you can check it out.
Check the first chapter. But yeah, for example, we say, are you not listening? But yeah, maybe let me show in the PDF. it's like it's not so nicely. It's how to spot how to spot a graph shaped problem. Yeah, it's not so easy because PDF is not so nicely structured. But yeah, basically we go into how to. I should be here. How to spot a graph shape. Okay, problem, and for example, like the typical use case is like the terminology is like self-referencing relationships, where basically you have like a single entity, like for example user, and then like just one type of relationship between user. Right? So in SQL, I think that would be like self joins. But in graph database, there's just like a nice graph. So basically, you have like users who have relationships between us. So it could be friend, that they can send money between each other, or like if you want to be more technical, you could have like, for example, dependencies, like let's say Python dependencies, and then see, okay, if there's like a vulnerability detected inside a package, what are all the packages that it influences that, because you can then just reverse depends on relationships to do that. So that's like one type of graphs. Another type of graph is the like pet finding networks, right? Where you have basically you're searching for shortest paths, because you can also think like Google Maps, for
Oh yeah.
example, right? They have, you say I want to go to Berlin, right? And then the locations are nodes, and then you have different options. And like even on Google Maps, you can choose, do you want to go by like public transport, do you want to go by car, do you want to go by bike, do you want to walk, right? And depending on the transportation mode, there are different paths, and it also like different cost. Like for example, the cost in Google Maps is time, right? How much time do you need?
Yeah. Yeah.
Okay, so that's like another like classical example for when to use graph databases and graphs. And then the third one that I showcased is the so-called like bipartite graphs, where you have uh, like two types of nodes. So, for example, user and item, and then you have which user you have like their purchasing history, right? So which user bought which item, and these types of graphs are very frequently used in recommendations, right? Because you can, or in e-commerce in general, right? Because you can use these graphs to find similar users, like groups of similar users, and that like if you use fancy marketing lingo, that means like segmentation, right? Groups of similar users, or you can also use this information and for recommendation, right? So if me and Alex have similar tastes, like similar purchasing history,
Yeah.
it is a good chance that if you buy something new, I might also like it, right? Because we had like similar purchasing history. So that's also quite similar, frequently used. And it could also be not just like for purchasing, but for example, like also like Spotify, you have like playlists and
Well, yeah.
songs, right? So it's a lot of these use cases. So that's like I think the three use cases that I showed. Or actually, yeah, I did four. Yeah. And then because I just said complex networks, but like because Neo4j particularly labeled property graph models are very good for representing highly complex and heterogeneous information, and which is highly connected. And like biomedical, so this is one image that I didn't draw. And like biomedical networks are like prime example of like heterogeneous and very complex connected information, right? Because here, for example, you have genes, and genes interact with genes, but genes also interact with compounds and diseases, and then it can upregulate, it can downregulate, it can probably associate when you don't know exactly what it is. And it's like highly complex and everything is connected, right? And knowledge graphs, or you might call them knowledge graphs, shine in that data representation, and then it can also allow you to analyze direct connections, right, but also indirect connections that are also might be useful. Because, for example, in the previous example, we said if two users are similar, right, you might recommend new items based on that. But for example, it's also like that two genes, you could identify that two genes could be similar because they interact with the same compounds, or I don't know, I'm not an MD, but let's just assume something. And then you say, okay, if two genes are very similar, have similar effects, whatever, then they might also be used for similar diseases, and maybe like it can help you come up with ideas like what should we test, or at least prioritize, because people always have a lot of ideas.
Yeah.
It's just that you need some prioritization, right? What should we look at next? And then graphs can help you basically capture the existing knowledge, and then once you have that, they can help you predict the future.
Yeah, no, it's very powerful stuff. It is almost like it. It's pretty amazing what it can do. I would say we give the raffle 5 more minutes, so until 20 to the hour we will do the raffle. So if you want to take part in it, give it a go on Twitch or on YouTube if you watch it live. ! raffle, and you're in the pot, and then we draw in after that. So now's your chance to win the ebook version of Tomaz Bratanic's book that we are discussing today. Maybe next. I don't know how would you continue, but do you want to talk about maybe about your favorite algorithm? Is that something we could look at next? Something that you think is most interesting one, or something you think is a good one that gives a good impression of what they are?
What we can actually show is that what's quite interesting is with graph algorithms. I mean, it's similar as with most machine learning, but it is that you don't feed algorithms to your data, but you feed data to your algorithms, if you know what I mean.
Yeah, I know what you mean. Yeah.
So we can take a look at one example for Twitter that I am certain you have seen before. But it shows quite well like the power of indirect translating indirect patterns into direct relationships. And it also shows the power like of why it's useful to have a graph database, because like you can run like graph algorithms anywhere, right? But usually running, it's like the same thing as in machine learning. Just running like a machine learning model or training it is very simple, but doing the feature engineering and preparing the data and massaging it and so that it nicely fits, like that's the big problem. So that's something that I show, because it's actually I think chapter 5 we show in chapter 5 we show we start with graph algorithms, but then in chapters 6, 7, 8, I think maybe also 9, I'm not sure, we show how to feed the data to match graph algorithms input, right? Because mostly
Okay.
the graph algorithms are designed to run on a simple graph, so like single node and single relationship type. They aren't designed. So like the typical example is like people friend, right? So that's like mono per type, mono meaning one, per type meaning I don't know. But like something like one type of nodes and one types of relationships, right? So it could be like I said, person, friend, person. But here in this example, for example, in the Twitter example, it's very famous with tweets, right? Because you can write a tweet or a post nowadays, but then somebody else retweets it, right? So that's like a relationship kind of between the person who wrote the original tweet and the person who retweeted,
Yeah.
but it's not a direct one, because here, for example, you can see that Sasha published a tweet. Oh no, actually it was Francois who published the tweet, and then Sasha retweets it, right? So it's not like by how you say raw data. In raw data, there is not a lot of there's no direct connection between the two users, right? But then you can make assumption. Okay, if I retweet your content, that means I like your content and I want to share it with my audience, which is a fair assumption, right?
Yeah.
And you can say, oh, okay, so that kind of means I am amplifying you, or because here I meant amplifying, and you can like use Cipher to say, okay, these indirect relationships, so that goes from user to the retweet, from retweet to the original tweet, and back to user. You can say, okay, this pattern for me, I want represents a direct relationship between two users, and that means that Sasha amplifies Francois. And this is basically how you're reducing or transforming indirect relationships to direct relationships. And that's like a big part of graph algorithms. And like I said, also it's like 4 chapters in my book just showing how to basically massage and transform data to fit graph algorithm input. Because I think that's the most important thing when you're like a data scientist or like analyst, right? When you have like nice clean data, it's very nice, but like in reality, reality is often very different.
Yeah, it's really very clean and nice. It's
That's
often
why
a bit of a mess.
big emphasis on first like exploring to see what's happening inside your data, how because what are some how you say characteristics of the data set, or like maybe it's something that you messed up maybe, or is something that like the one who designed API thought that it should be correct, like, but it kind of doesn't make sense. Because, for example, when I scraped the Twitter right via APIs, like long time ago, you could still use API.
Yeah.
I learned that, for example, every time you retweet someone, by like default, it's also a mention, right? I don't know why, but that's just how it is. Like under the hood, that's how you get it from the API, and then you need to take into account these anomalies, right? So what does the data actually mean? Kind of have to dig deeper a little bit and explore and see like is this like a characteristic of like the network, is this characteristic of the like implementation, what does it actually mean? Because it's not like just running algorithms, it's also interpreting results, because that's like the most important thing. You run an algorithm, you get some numbers, and if you don't know what to do with those numbers, what do
Yeah.
they mean?
Exactly. What do they mean? Yeah, that's very important. Yeah.
It's useless, right?
Yeah.
You say, okay, Alex has PageRank score of 5,
Yeah.
and whatever.
What does that mean? Yeah, nobody knows.
Yeah, and then you have to go a little bit deeper. So yeah, that's like I said, transforming data sets and like massaging is very important, because I have, like, for example, another example where basically you don't have any relationships, you just have a feature vector.
Mhm. While you're looking for that, I would say we close the raffle. So I think we already over time anyways. From what I said, we would be doing it. So I'll close it. So everybody that's in the pot by now, you have the chance to win one of 3 ebooks, and I'll pick the winners as well through the tool that we are using here. So it's all random. It's all very safe. So don't worry. I'm not picking anybody by their name or anything else. It's just the tool is going to do it. And the first winner is Martin. Congratulations. The second winner is Salman, and the third winner is Anmol. Congratulations to you 3. So you see here, if you won, then that's it. If you did win, please send me a email and reach out to me at alexander.erdl@neo4j.com. I'll post my email in the chat, and then you can reach out to me and we get the link over to you. I'll do that in a bit. And yeah, with that, back to you, Tomas.
So actually, I decided we're not gonna look at nodes with no relationships or like feature vectors, because here we have more prettier pictures.
Okay.
I mean, like, for presentations, prettier pictures are better. So, for example, another way how you could like turn like sometimes people call them implicit relationships or like indirect relationships between entities, and turn them into direct relationships so that you can run graph algorithms on top of that, is the so-called co-occurrence networks. So that just means you kind of define a co-occurrence between 2 entities. And for example, here in this example, I think we have like medical keywords and how often they occur in the same article. And then that kind of helps you to find like communities of similar entities, or like how they are kind of related. So what's the what's showing up very frequently. So for example, we have anti-anxiety agents, and they co-occur with hypertension, right? And that's something that was just automatically generated, but taking a look at how often do entities co-occur, like medical entities co-occur in the same article, and then we have maybe more the I say popular ones. So, for example, you can also take this approach and just look at Harry Potter, right, and see, for example, if two persons here characters are within 10 words of each other, they appear within 10 words of each other in the text. That by definition we define like an arbitrary limit, and let's say we define 10 words, and then that means that they kind of co-occur. And if we take this algorithm and run it through the whole book, we can then construct a graph out of the co-occurrence relationships, right, and see who interacts with each other, right? So, for example, Petunia Dursley interacts with Dudley. But I think this is the first book, and Vernon. And then, for example, obviously Harry Potter is the main character of the book, so it's the largest known. Then very close to Harry, Albus, Ronald. Hermione is slightly more far away, but then you can see kind of how characters group together, right? And then you can also, for example, you could use a kind of set. I didn't use like community detection algorithm here. Then you can find like.
But it could be an add-on. You could.
Yeah, I mean, you could. I just unfortunately didn't add colors, right? Because colors make the images also nice.
Yeah, yeah, and then he's.
So, for example, here we have like when like here we have a co-occurrence network of ingredients in dishes. So, for example, when two ingredients are in the same recipe, right? We say that they co-occur, that there is a relationship between the two, and then the more frequently they are in the same recipes, the stronger the relationships between the two, right? And then we can use this, for example, here to analyze communities of ingredients. And for example, you can see that like eggs, flowers, sugars, milk, that is very frequently used. So that could be like, that's like most of the baking stuff, right?
Yeah,
Yes.
that makes sense.
And then like in the, I would say like main dishes, it's onions are very vital, right?
Yeah, more like savory. The other sounds like more like cake ingredients, and this more like tomatoes, onions, more like
It's like
more savory, a bit more,
Yeah, and then you can, for example, onions, and then you can add like chicken, pork, like or tomato sauce, potatoes, right? So, and you can, if you dig deep into it, you can kind of, because I know like that they did like some analysis of foods from which cuisine, so like from which countries, and then you can do like these visualizations for each country or like each region. And it's quite interesting to see differences between different regions, how they combine ingredients, for example. So that's always nice, because the nice thing about like when you're dealing with small graphs is that you can visualize them, and they make really nice visualizations for demos, presentations. But like when the graphs are too big to visualize, and that happens very soon, that even like 1,000 nodes, it's beyond any like it's not you can't find a lot of insights looking at 1,000 nodes, right?
No, that's not gonna work.
So that's when graph algorithms come in. So you can think of how I usually explain it, like when you're dealing with small networks, you can say, okay, egg, flour, and for me it's funny, it's peanut butter. So I think this is very American skewed. Americans get a lot of peanut butter. And like I said, yeah, for like small networks like this is maybe 50 or 100 nodes.
Yeah,
You can see these relationships and kind of patterns, and it kind of makes sense, right? But like, let's say you're dealing with even 10,000, but you can be like in the millions, right? What you're gonna do? You're not gonna look at million nodes and kind of digest something. You hope to find nice, right? So because you can't do that, like at least in a timely manner, what you do, you use graph algorithms. So graph algorithms are then kind of your substitute for when you can't like manually find information, then you use graph algorithms, which like programmatically they use some fancy mathematics.
Yeah.
And they find those insights for you, and they say, okay, these are important, these are communities, maybe these are how communities change over time, or I don't know. So yeah, so that's how I would. That's what I would say about graph algorithms. Is basically when you're dealing with graphs that are too big to visualize, that's when you want. And I mean that happens quite fast.
Yeah, that's cool. We have a couple questions. Tomaz, do we wanna?
Yeah, I mean we can.
Do we wanna go through them before we wrap up, or?
Yeah, we can look at some questions.
Okay, cool. So one comes from Salman. He asks, will this library be available for free on Aura DB for learning and for experimenting, or maybe to rephrase it because I know already the answer? What's the best way of exploring and try out and learning graph algorithms in the Neo4j environment? How would you recommend starting?
So I would actually recommend Neo4j Sandbox because I can show. So Neo4j Sandbox is there's a bunch of projects. You can, for example, take a graph data science project. You can actually look like libraries enabled, and then if graph data science is enabled, it kind of implies that some algorithms are in there that you can use. So if you're like completely new, you don't know, you just want to try it out and test, I would recommend spinning up, because it's like a free cloud instance, right? You just click on create, wait a minute or maybe less, 30 seconds, and then you can open it, and it's got like nice guides, and it hopefully handholds you.
Yeah, and it has already the data, so you don't have to worry about getting something there. And to answer to completely answer the question, on Aura DB free, Cloud Data Science Library is not available, so you are currently not able to try it out there. There is a paid tier which allows you to use the Graph Data Science Library, but not on the free tier of Aura DB. So yeah, the sandbox is going to be the best way to play around with it and to see what it is.
Exactly.
Cool. The other question comes from Lavanya. She asks, what are some known challenges of the Cypher language implementing custom graph algorithms as a complex query? E.g., the with statement only always maintains modifies a table structure. Knowing these challenges would help users to look right, these algorithms in the backend? Maybe that's a bit of a longer question. And
a long question, but
yeah.
what I would say is that like what you're saying is that like you want to write your own custom algorithms with Cypher, and yet there's like a lot of I mean, there are like no challenges of Cypher. There's like someone can write a book and I mean, and talk about it. I mean, I'm not saying that there are a lot of known challenges for Cypher because I honestly don't know. But it's like this is like a big topic.
Yeah.
But what you should know is that. Like in the book, when we are referring to graph algorithms, we are not referring to actual to implementation in Cypher, but in Neo4j you have a graph data science library that exposes graph algorithms to do procedures, right? So if you want to run PageRank, you just say, okay, I want to call GDS PageRank.stream, so I want to run a PageRank. So that's all you need to do. It's not like now you go into this PhD math mode and you look at the original paper and then use Cypher to implement the original paper. I mean, that's like only a handful of people know how to do it. But for the rest of us, we just kind of abstract the complexity away and just use procedures to call graph algorithms.
Yeah. Cool. And the next question comes from Mac. He asks, is Neo4j suitable as a replacement for vector databases? I think we talked about vectors. You talked about it a little bit.
I mean, that's also...
I know. It's also...
topic. It depends. Most of the time, yes. There are probably some cases where no. And it depends, like, exactly what you're doing. But in theory, I would say most of the time, yes, not always. So that's like a very nice political.
yeah. No, yeah, but that's hard to say, and it's always difficult if you don't know exactly what.
I mean, things are changing, right?
Exactly. Yeah.
You don't know what's gonna happen in 1 month. So.
Yeah, absolutely. Cool. I think that's all the questions I could at least see right now that come in. If you have any other questions, then please obviously reach out to the community either on Discord or in the community forum, or comment down on below this video on YouTube. We'll have a look out as well for anything on there. Anything you want to say before I close us out, Tomaz?
Yeah, I want to say thank you to Ashford. He said it's a very nice book.
Yeah, thank you, Ashford.
Thank you.
Yeah.
So that's but yeah, like I said, the idea. So if you don't know anything about graphs and you want to kind of, if you want to start, then I think it's a good book. Obviously, I'm biased, right? But it's a good book. But if you already know a lot about graphs and graph algorithms, for the last 3 chapters, actually 4, I have the code on GitHub because we use, as you can see, Spacey, for example. But like also like machine learning libraries in Python, and you can take a look if that's interesting for you. Obviously, there is no copy, there is no text in notebooks because it is what it is. But I don't know if you can also maybe just share this link if people want to take a look at some of the latest chapters. I mean, it's fine for me You can, if you're just interested in seeing what's the code, and what maybe to expect by the end of the book, you can take a look, run the code. Yeah, the code should run if you have no idea anyway, and then you can decide if you like it or not. And
Okay, cool. Yeah, no, thank you very much. Thank you very much, Tomaz, for obviously for writing this book. Thank you, obviously, also to Michael for making you write this book. So it's really good. If you didn't win the ebook, we have a 35% off discount code that is also in the YouTube description in the video. So if you wanna buy it, Tomaz has a discount code, and you get the chance to get it for a little bit cheaper than the list price. And thank you very much for the cool presentation. Thank you for showcasing us or guiding us through the book. And thank you everybody for participating today. The next stream is going to be on the 25th of April, so this is going to be next Thursday, where Martin and I we will talk about the Neo4j and LLM fundamentals course that's happening, or that you can already participate and try out yourself on the Graph Academy, and we will go through the basics of the concepts of the what to expect there, what you can learn there, and how it works in the stream next Thursday. And if you between now and then basically want to know what's up, then check out the Neo4j community on Discord or on the forum, as I said before, for any questions, anything, any open discussions, anything else where you would like to talk about, and you have issues and want to discuss or network with Neo4j folks and experts. If you want to learn more on the Graph Academy, then please check that out as well. That's a really good place to learn about graph databases and also graph data science. We have courses as well for this. So maybe it's a good combination to try out one of these courses on the Graph Academy and then also read the book from Tomaz. And if you want to play with it, you can use Neo4j Aura Free, which obviously gives you a database on the cloud, but does not work with graph data science. So I think that's really a bit of the downside here. But you can use Sandbox instead, as we discussed. And yeah, with that, thank you all for watching today. Thank you for participating. Thank you for your comments and your questions. I hope you had fun, and I hope this was informative and interesting to you. If you want to know anything else, then reach out. And with that, thank you very much. And thank you, Tomaz. Have a good rest of your day and see you soon.
bye.
Thank you. Bye-bye.